Hey, welcome to the Pragmatic Security for SRE. I'm really glad you're here with me today, and let's dive into why security can and SRE can really gather together and kind of unite around this pipeline of how we're delivering software to our customers, and where those interfaces can happen, and maybe it'll help spark some ideas of whether you can bring back to your team that'll unite people over a shared problem, over a shared solution, which is really kind of the engineering approach that we're going for. I'm excited for this talk and to kind of dive into what it means for SRE as we think about our pipelines and we think about how we can inject security at different places. My name is James Wickett. I'm the head of research over at Verica. I also help run the DevOps Days Austin and the DevSecOps Days Austin conferences. You know, it's hard to imagine when conferences are back, in-person conferences are back in session, but we're excited for that day whenever it does come. I'm also a LinkedIn Learning author, and I have courses on DevOps and DevSecOps, along with my friends Ernest Muller and Karthik Gaikwad. We have some courses that would love for you to check out if you find this interesting or helpful. I have some links to some of those throughout the talk as we go. And if you want to find me, you can find me at wickett.me or on Twitter at Wickett. And let's dive into it. Now, before I get into it too far, I'd like to tell you about something. I'm going to be going through several books throughout this course. I have a couple quotes to really help set the stage for the problem statements, and a couple books that I think are really helpful as you're tackling different part of the problems, in regards to audit and other stuff. But one of those books is Chaos Engineering. In it, there's a whole chapter called Security Chaos Engineering, written by Aaron Reinhardt. But the book, Chaos Engineering, is written by Casey Rosenthal and Nora Jones. And all the other books, I don't have access to give them away for free, but this one I do. If you go to verica.io/book, we've sponsored the book, and we'll send you a full PDF of it today. So enjoy that. Hope that's helpful for you as you're kind of going through this journey. I also have some books that I'm going to mention that aren't exactly real, but probably apply to you in real life. If for some reason, you kind of get stuck, you have to go back on the recording, or there's something that's troubling you with how to deal with security as you're kind of going through this process, just reach out to me on Twitter. I'd be happy to chat with you. Or my email over at Verica is wickett@verica.io. And again, be happy to chat with you. Well, and this talk is really kind of representing a growth of like how we think about our pipelines and how we think about security inside the pipeline and where that fits in the SRE movement. And so, it continues to change, it continues to evolve, but I'm really glad to be able to share this with SREcon today. Well, I think we should talk about security. So let's kind of dive in on that. I'm going to use a couple quotes from some key books that I think are very helpful, but also really set the stage for what the problem is that we're dealing with here. Steve Belovin says this. He says, companies are spending a great deal on security, but we read of massive computer-related attacks all the time. And clearly he goes on to say something is wrong. The root of the problem is twofold in his opinion, that we're protecting the wrong things and we're hurting productivity in the process. We're protecting the wrong things because we still keep reading about breaches like all the time. And we're hurting productivity because we're slowing things down. No one thinks, oh, I really want to get security involved in my project so that I can go faster, right? So because you have both of those happening at the same time, it's particularly damning for the security, part of your organization. They're not keeping pace and they're not stopping the problems. It's really problematic for most of them in most organizations right now. Secondly, security, if you follow it throughout the decades of how security engineering has been going on and taking place, it was about the 90s whenever we sort of traded the idea that we were engineers to the idea that we're going to do actuarial science. This quote in this book, Tangled Web, is really helpful to unpack that. Let's read it. Security by risk assessment introduces a dangerous fallacy that structured inadequacy is almost as good as adequacy, and that underfunded security efforts plus risk management are just about as good as properly funded security work. So all we got to do is add a little risk management. We don't have to fix our code. We don't have to design for security. We can just add in risk management, buy an insurance policy, and we'll be okay, right? Right? That sounds good. It's one of those things that seemed like a good idea especially when facing all the legal and audit and other problems that there were compliance problems that were happening in that time period. But we've continued to not invest in security engineering and put more money on compliance and audit frameworks. And sure, you definitely need some of those things, but I think we've overinvested in many organizations in that. Security often gets branded as the kind of people that always say no all the time. Well, the Agile Application Security book says that many security teams work with a worldview where their goal is to inhibit change as much as possible. You know, that's one of those things that it sounds like, oh yeah, well, we'll just kind of stop all the changes, right? But people just work around it. You know, we had this whole movement of shadow IT, and hey, in operations and you know, we saw all that too, right? This isn't something new to us. That's just a problem with security. But security has continued to have more problems with this, I think, even than operations did over the years. My friend Wendy Mather, longtime security industry expert, in response to how do we pronounce the word CISO, is on a Twitter question for an InfoSec question here. She says, it's pronounced scapegoat. And I think that's really fitting because CISO, is one of the old joke goes, is like, you know, you just become a CISO and you got 2 years there because you're eventually going to get fired whenever the breach happens that you didn't really cause, but they need somebody to fire when that happens. And this is one of the not real books, right? But you know, a lot of times we just think we want to get around to security at a later point. Like we want to build it to get it working now, and we'll secure it later. Well, all this is problematic. Security faces, you know, they're ineffective. They're often understaffed. They've been replaced for, you know, insurance. They're often blamed for everything that happens inside of organizations. And I started thinking, like, what happened in DevOps that brought operations along to, you know, into the journey of how to deliver value for everybody inside of organizations. And I really like Patrick Dubois' quote in this, I think it was in the Cutter IT Journal, where he was saying, can DevOps work for the enterprise? And I think it was circa 2012. So quite a while ago. He says, culture is the most important aspect for DevOps to succeed in the enterprise. Culture. Right. And back then we were all saying culture, culture, culture. We really probably still should be saying that now, but it is. And we need to extend that to the security teams because they're facing many of the same problems, many of the same siloization effects that we faced in the DevOps community for many years. And so now that's what DevSecOps is. So I know some people don't like the term, some people think it's overloaded, but DevSecOps is a continuation of the DevOps movement. It's a cultural movement that's bringing security in for Agile and DevOps and security. But where does that leave us here? Why are we talking about DevSecOps? How do we just get it done for SRE? Well, that is exactly why I thought this would be a good talk for SRE and wanted to bring it to y'all because SRE, that's the people in the organization that actually get things done. And so let's see if we can get SRE to the rescue and help bring security and you know, inside of our pipelines and make it useful in our organizations like we hope that it could. Now, there's another book, Building Secure and Reliable Systems. This is a recent book. It's really great. In that book, one of the things they talk about frequently is the trade-offs between reliability and security. Stuff like if you add more redundancy, really good for reliability, adds more attack surface for security. Or if you're trying to solve an incident, reliability would state, you know, bring in a lot of people from diverse perspectives, try to get everyone together. Security, you want to limit the blast radius. Don't, you know, it's a, like limited need to know type of organization. So, you know, there's some trade-offs on both of these. So there's not like a simple right answer for anything. Also, I want to explore with you something that I found really interesting. When you look at the DevSecOps survey, which they have done several years in a row, and we're going to pull up some of the data here. People that are doing DevSecOps, that's this blue line here, the data. And I think this is the 2019 results, but the 2020 results are very much in lockstep with this as well. But they outperform their non-DevSecOps or non-DevOps leaning counterparts by what I think here it says 350%. It's a lot more in any sense that you want. So if you look across the pipeline, and they break it up into these 6 phases of design and development and build and QA and test. And it's like, oh, okay, that's really interesting. As you start reading that data, you think, I really want to do this. This sounds good. It's way better. Of course, I want to do it. And then you start realizing, what are the tooling choices that they're actually implementing across the pipeline. And you start looking at it's like web application firewall, container application security, open source governance, static code analysis, dynamic code analysis. Okay, well, none of those are novel or new. It's not like something that we haven't had a whole brand new whole cloth classification, of tools that we're bringing out here. These are things we've had inside of the security world for many years. Like web application firewalls are like close to 20 years old now, and same thing for static and dynamic application scans. I guess you could say the container security piece is kind of new, but even that's, it's been around for a while. They're not taking brand new approaches. What they're doing is they're taking the current existing security tooling and moving it to the left, shifting left, kind of putting that into other places inside of their pipeline where they can promote feedback and where they can get applications that developers that are actually working on the system involved in the security of the system. So this is where I want to think about how does the security tool chain for CI and CD work? So there's a lot of different ways how you can break this thing up. Here is a somewhat simple logos NASCAR slide here. Here is the SANS, mega list of all this stuff. Very worthwhile taking a look at. I think it's helpful to go down these and say, like, what tools are applicable to my systems? What tools can I put in place in my organization? As I work more through the deck, I break the pipeline up into 5 different phases, and we'll look at some tools for each one. None of them are meant to be prescriptive. They're meant to be an example of stuff you could do. Something like this list or other resources online would be helpful for you to find, like, depending on your programming language or your CI system or what kind of cloud you're using, it could really help uncover that. I got this idea for this talk several years ago from my friend Shannon Leitz. She was talking about secure software supply chain and how she would ask questions at each part of the supply chain. And I thought that is really helpful because it takes security and it takes it out of the place of, like, it's the thing that we do at the very end once it's in operations or once we want to, like, pass PCI or trying to get our certification or compliance or whatever it is that drives us to do our security. But instead thinks, what am I doing at these different phases? So big shout out to Shannon over at Intuit, and she's at DevSecOps on Twitter. But let's talk through those 5 phases, which I've kind of teased at, but let's break it down here. So there's develop, inherit, build, deploy, and operate. 5 phases. You may consider 4 inside of your infrastructure. You may split up, develop into like 2 or 3, and like have design, an architecture built in there. This is just how I broke it up. This is how I logically want to think about it. But you're welcome to kind of bring this to bear in your own infrastructure, in your organization, bring it into the vernacular of your own context there. So we're defining develop as this design and development of an application and its features, including all the development practices like version control and sprint planning and unit testing. So what are some of the security activities and considerations that you should look for in this phase of your pipeline? Things like threat modeling can be really helpful, although sometimes really challenging for a lot of folks. Security stories inside of your Agile boards. Making sure you have the right authentication for being able to commit code to your repository. What kind of development standards do you have as a team? Are you doing peer review? Do you have static code analysis put in place? Do you have any unit tests that are specifically geared or written for security stories? I think those can be really helpful for us. So when we think of threat modeling, there is the threat modeling book, which is helpful. Also, OWASP has an application threat modeling cheat sheet, which is linked in here. And these links should be still working in the slides. If you download the slides, let me know if for some reason they're not working or we need to get another copy of that. There's some things like creating evil user stories, and there's a link to a resource on how to do that. One that I've had good luck with is the Mozilla Rapid Risk Assessment. And what it does is it breaks up the threat modeling exercise. Instead of doing it, for a couple of days and then going off and building the system and then find yourself 6 months from then and thinking like, wow, how's our threat model? It's like, it looks very divergent of what actually our system looks like. The Mozilla Rapid Risk Assessment breaks it up as where, like, that's a card inside of your sprint. And so you do 30 minutes to an hour per sprint on your threat model, answering one subset of the questions. And it's a really helpful document that kind of brings that together. But as you build it out, sprint after sprint after sprint, you kind of build naturally your threat model at the same time. So it's really, really cool. Would love to hear as people have success with that or try that out. These are just tools and practices that you can put in place to help as you're kind of undergoing this phase. The next step is like development standards. Do you have pre-commit hooks for security? Do you have coding standards? I mean, security or otherwise. I mean, sometimes just misconfigurations can be some big security holes as well. Of course, this is SREcon, so I would assume that we're good here. But I'm just mentioning this, especially as if you take this and you want to hand this off to a security person inside of your organization, or you're getting other people bought into it. These are some things that may not be top of mind for them because maybe they're more, just carry a different mindset on how they're thinking of this. Being able to do peer review, doing single mainline branch, making sure everybody's code is up to date all at the same time. So some of this is like just coding and hygiene standards that we've kind of learned through many years of practice, but it's really helpful to kind of bring forward to security as well. I find just doing good linting and code hygiene stuff is really helpful in this stage as well. So some code standards, like let's say if you're using Go, Go Fumped, and Go MetaLinter are two choices, and Go moves kind of fast, so I don't know if these are even like the most up to date at the point, but you get the idea, right? What we're trying to say is we'll always make sure that our code looks the same. We're all making sure that we're participating the same. We're linting our code with the same tools. That helps inform us as a team as we're building software. We're trying to keep secrets out of our code base. Like there's Git secrets, Git hounds. There's Talisman, repo supervisor. The idea is we're wanting to make sure that we're checking for any of these sort of vulnerable, they're not vulnerable, but we're looking for any exposure of secrets inside of the code base, and also looking back in your Git history is important as well. So what we're really saying here is that a bug is a bug is a bug, and we don't treat security bugs any differently than we do development bugs of any other type. We're not saying that they're this special class of vulnerabilities. And so we're taking security testing and we're putting it where all the other error testing lives. We're putting it in the ID, we're putting it in our local build environment, we're putting it in our CI system where we would do all the other stuff. So if you're kind of thinking, yeah, those other things are hygiene or linting, but they're not really security specific, I would just say security bugs are they're mistakes in code that are exploitable and that people can actually find and make some sort of exploit out of. We don't really know whenever we're writing code if we're actually writing a security bug or just a regular bug, and we're not going to know until much later. So, okay, so I think this wraps up our development. Oh no, this isn't. We must always figure out how to exit Vim. Then we actually have a couple more slides here in the develop phase here. So we have the static code analysis piece. And this is not unfamiliar territory for security pros. We've been doing this for a long time. It's static application security testing. Sometimes nowadays you can have where there's an IDE plugin that'll work. There's open source tools. There's some paid tools. Depending on your language, you're going to want to find which one works for you and which one will give you the results you need. But I recommend it. Here's a list I put out on Twitter and gathered some like GitLab and SANS and OWASP and other things, but like types of tooling, scanning tools you can use for the language that you're using. So if that's helpful, go for it. But I think you'll just find whatever you're using, go for it. The last, we need to think about unit testing. So as we're doing unit testing, that is something that is the currency of developers. And one of the things I often kind of tell security folks is like, if you're not doing things to help for the benefit of developers, you're kind of doing it wrong. So go after the JUnit stuff or the RSpec or whatever framework you're using. And the goal is to have your security tests being written in the same language and being written in the same side by side with the other unit tests. And that doesn't matter if you're using TDD or BDD or ATDD or whatever. Figure out a way how to get security writing tests alongside of development. And so the questions that we want to ask, which is kind of a call out to what Shannon was doing over at Intuit, Are the developers testing for security locally before it gets into the CI system? Are we practicing good hygiene and good coding practices? Are we preventing secrets from being, leaked into version control? Those are what we want to seek out for this phase of the pipeline. And there could be more, but these are some of the starting questions as you're kind of breaking up your pipeline and thinking through what do we put at that phase to help us. Okay, let's move to the inherit phase. So this is kind of a controversial phase to put as a separate thing because many people would just say, well, that's part of your development phase. But I wanted to call it out specifically here because it's overlooked. It's the most invisible part of our code base because of all the software dependencies that get bundled in and inherited in our own system and upstream. And so also not a real book, but certainly could be. I know that we've all felt this pain. In modern development, we're bringing in a lot of dependencies and libraries and using their frameworks, and it can kind of feel like this fictional book, and that's what we're thinking about at this inherit step as we're kind of breaking this down. So what are the security considerations for this? Security, this is our real line of code count, right? This is not, I wrote this 50 line or 200 line, serverless app, right? In fact, like when you start looking at those, like you realize quite quickly that the frameworks and dependencies and all the stuff that you build in for that 200 line app can quickly balloon to 200,000 lines of code, 300,000 lines of code for all the pieces that you're actually exercising. And this is just how modern development works. So we have to really think about our software delivery supply chain, making sure that we have a published bill of materials that we can trace back our software to know where it is. And now most people don't even have this. And I think like just having that level of intelligence and insight would be really helpful. And some of the SRE discipline and like how we've done this for many years or trying to lock this down on the operations side, this can be really helpful as we're kind of bringing security in and trying to help put this even further together. But this is not just our application dependencies, but we're also thinking, OS level, and we can still probably faintly remember, shell shock and heartbleed and kind of all the pain we felt in those days. And so as we look across our tooling choices for this, we can look at things like bundler audit, OWASP dependency check, which is an excellent tool. Totally recommend that. NSP for Node. And then there's a bunch of paid options. If you want to just do JavaScript and JavaScript only, like a really cheap and easy one that you can put in your CI/CD pipeline, very quickly is retire.js. So check all those things out. These sort of things can help us understand what are we bringing into our pipeline, what are we putting into our code base that is actually getting exercised by real customers and potentially real attackers. And don't think just because we're using containers that we're safe. In fact, we need to be even more skeptical, or we need to even like take a real disciplined look at like the types of containers we're using. Building your own containers is optimal, but making sure that you're using some sort of tooling to inspect and understand that. So, what are some of the questions we can ask? Like, what have I bundled into my application that's making me vulnerable? Am I publishing a bill of materials from my application? Okay, so many people think of this next step as kind of the main, point of CI/CD, and this is where the CI build system runs. It does all the acceptance testing, all the previous testing and tooling gets verified here, in kind of a trust but verify model. We're doing outside-in security testing for the first time. We're thinking infrastructure as code testing. We're actually able to exercise the application using DAST. We're doing compliance on every build. We're using containers where possible to help simulate this stuff. So what's a DAST? You might already be kind of familiar with these type of tools. They do require tuning. They're not easy to use. Sometimes you can run them and they will find lots of problems or no problems, or they'll just hang. There's a lot of variations of them. There's paid ones, there's free ones. Nikto, Arachne, there's some of the ones that you can think about there. SQL Map is another one. All good examples of stuff that can work, but don't always find what you would hope they would. So what do you do with these? So the goal of this step should be to come up with a set of automated tests that probe and check security configurations and runtime system behavior for security features that will execute every time the system is built and every time it's deployed. That's what the Agile Application Security book says, and that is in that chapter they're referencing Gauntlet, the tool that I helped work on and build. It's an open source tool. It's a framework that takes care of doing this sort of outside-in sort of security testing inside of your CI/CD pipeline. It's written in Gherkin. It's pretty easy to understand. You're just making a statement of like, I want to look for cross-site scripting using one of the scanners, in this case, Arachne against a URL. Given I have it installed over here, it's not, Gauntlet's not packaging or anything. And then when I launch an attack using these flags, the output should contain, this message. It's all containerized now. You can get Gauntlet in a container, and that's the best or most recommended way to use it. You can put it inside of your pipeline. Aaron Reinhardt, whenever he was over United Healthcare, he says they saved millions of dollars using Gauntlet for the largest healthcare industry project out there. So that was really fun for us to be part of that. If you're interested in security testing with Gauntlet, I have a whole course on that in the LinkedIn Learning library. Okay, so another piece is the infrastructure and compliance piece. So using things like server spec or inspec, which I think is really kind of the way to go nowadays, and to be able to test your infrastructure as code there. And the questions we want to ask across this entire step of build is, am I testing for security low-hanging fruit? Am I arming my pipeline with the attack tools? So I'm actually using the same tools that attackers would use to attack my application. Have I validated the previous two phases of the testing in a secure build environment, and then generated an artifact that is functional, that we know that we can trust? Okay, the next piece is the deploy phase. So this is the phase where our software is moving from testing to where customers are able to actually operate it for the first time. And this is the book we all read when we enter into the deploy phase. Part of the secret prayer that we all say is we release our software into the wild. So what are the security considerations we should look for in the deploy phase? So we're looking for compliance. We're looking at secrets management. We're making sure we have accountability for our deploys. We're doing authorization and logging. We're monitoring deploys. We're the execution step as infrastructure as code, and we're making sure we have repeatable execution. A lot of the pieces a book that I really enjoy and was really helpful for me is Continuous Delivery by Jez Humboldt and Dave Farley. Now, this isn't a security focused book, but it helped me whenever I was over at Signal Sciences, which is my previous company. I built out Deployer, which was our automated deployment system, which did all this security testing that I'm talking about now, and was able to deploy that into the cloud. I saw it run for at least 10,000 times, 10,000 deploys in about 2.5 years. And what was really great about going through that process and kind of taking that continuous delivery book and thinking like, how do we add security into it? I was able also to reference this book, and it was helpful. It's like deploys can be treated as standard or routine changes that have been pre-approved by management and that don't require a heavyweight change review meeting. So we sort of took the view that separation of duties is considered harmful. I know that's quite a hot take, but if you find yourself having to deal with auditors or compliance people that don't agree with that, I have a whole bunch of links here, and some of them come out of the Agile Application Security book, and I think they would be really helpful for you as you're dealing with it. We also have the Dear Auditor project, which is dearauditor.org, which writes a love letter from security to compliance. It says, hey, we'll bring you along. We'll be transparent. It has a DevOps security controls matrix that can be really helpful. So people are discussing this. How do you deal with auditors and bringing in compliance along for the journey? We're also thinking of, in the deploy phase, of how we make sure our cloud config is working out. So, Evident.io and ThreatStack and Alien Vault and a lot of all those providers, they do a lot of that stuff. But your cloud provider can tell you quite a bit. So CloudTrail or Inspector and GuardDuty are a couple of the Amazon tools. What we really want to know here, as the questions we wrap up for this phase, is what secrets are needed to move my application from development into production? Am I testing for compliance on each and every deploy? And is there a repeatable mechanism to push changes into production? And once we can answer assertively to all those questions, or we think we have an answer that's suitable, let's move on to the operation phase. So this is the phase that many here at this conference live and know. And these last phases, they're probably more and more familiar. Although I find SREs are often able to span the whole, be boundary spanners across the whole life cycle, from code commit to customer usage. So I think hopefully a lot of this has been kind of reminder or helpful for you. But the runtime stats, runtime state of the application, where users interact with or consume the application, and really this could just be our application in production. So it's just this kind of business where we're running in production here. So security in the operation phase is only successful if it creates learning feedback for developers. And I'll say that again, security in the operation phase or in the operate phase is only successful if it creates learning feedback for developers. So what are the types of places where we can get learning feedback? Well, we can do security chaos engineering because and that's a place where we're injecting, we're creating stability through injecting instability. We can add in circuit breakers and bulkheads. We can do application security, service abuse, and misuse. There's things like bug bounties, which have been around for a long time and common. Being able to do red teaming inside of your organization, also really helpful. And whenever I say detecting what matters or getting that feedback to the right people. So as you know, like as an account takeover attempt is happening, being able to give that telemetry back to the people who are in charge of your auth part of your system, or what part of the application are people doing that. Understanding what areas of our site are under attack, or like the OWASP top 10. Maybe it's not really the top 10 for your application. Maybe it's the OWASP top 4 or top 12. You don't really know. What are the vectors that people are attempting to attack, or people are getting some success in their attacks? I think sometimes we think that like there's a magical packet that an attacker emits, and then they own your whole system, but that's not really true. They have to get piece by piece, take land grab by land grab, being able to set a foothold, be able to pivot, move into other areas, try to compromise other places before they're able to get data out of your system or accomplish whatever goals they're trying to accomplish. So along that, there's a lot of noise that happens under that system. So being able to understand what vectors are people taking whenever they're trying to make these type of attacks can be really informing for your system as you're trying to defend it. Also understanding like what business logic flows are critical, being able to put like alerts and triggers on those is really helpful. Any sort of abuse and misuse signals, they may not stop from a very serious attack, but it would be something that would be useful as a way for you to understand what's happening. So Amazon has this helpful for their web application. They have a web application firewall for serverless that you can build for yourself, which is could be a little daunting to the uninitiated, but probably not too bad for SREcon. But it breaks up the lambdas into to bring in reputation lists, to score what types of actions they're doing. So this is sort of a kind of a roll your own WAF, but it's adding telemetry and putting it in places through lambda functions back into places where developers live and who wrote the code can respond to it. I think this is the type of runtime defense, which is, there's that whole roll your own that was on the previous slide. I think that one of the things you can avoid is like, we will often take something like application security, which is, really about the applications it's protecting. And we could roll it all the way out to the CDN or put it at like a, extreme edge of the network. And we're not really getting the telemetry that we really could use. And so there's a lot of, WAF and RASP options out there. Another thing you can try is Red Team Mondays. That's where you get a red team and they start attacking different parts of the system. And they will take an application and maybe they'll spend just all day going after that one target and seeing how good they can penetrate it. Intuit does this. Shannon Leaks kind of came up with this idea of Red Team Mondays, where everyone is excited to come in. They try to attack an application. And at first it was culturally a hard sell inside of the organization. But over time, they started having applications that people would say, hey, we're about to release, or we just released. Could you put us in your queue? We want to be on your next Red Team Monday. And so security, instead of being the department that says no, they started being the department that added value because they could find bugs, and not just security bugs, other bugs too. But they were like an additional step. And one of the managers could start asking like, okay, yeah, are you ready for release? Yeah, well, did you do your Red Team Mondays? Has Red Team Monday found you? Have you done anything on that? So it was quite a cultural shift that I find really compelling and really interesting that they were able to do. Another thing I brought up is security chaos engineering. And you may have heard of chaos engineering, which has proven that we can build more reliable systems by injecting faults and failures into them. Security chaos engineering takes those same principles. So we all know what the show is really about. And our systems are really too big to fit on our heads anymore. We can't. We don't have the 3-tier web application. That's gone. How do we create an operational security model on what's kind of a modern system? Security chaos engineering is the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. So what are the 4 steps to security chaos engineering? 1, you just define the expected behavior of the security defense. 2, you hypothesize, oh, what is the security turbulence that I introduce? Is it going to be prevented, remediated, or detected? Next, I introduce a variable that introduces security turbulence. So, some way to inject that failure or fault. And then try to disprove the hypothesis by looking for a difference in the expected behavior versus the actual behavior. If security chaos engineering is new to you or you haven't heard of that, go check it out. There's a new report that just came out, I think last week, 2 weeks ago, by Aaron Reinhart and Kelly Shortridge. It's called Security Chaos Engineering. Verica doesn't have the rights to distribute it or anything, so you can go just check it out in Google or find it through O'Reilly's website, but it is free as well. And I mentioned this at the top of the presentation, but verica.io/book, we can get you a copy of that. And there is a chapter dedicated to security chaos engineering in that. The last book I'll recommend is Nygaard's book. Nygaard's book speaks the same language to security people, although not specifically security, but it has circuit breakers and bulkheads, and there's a whole chapter on chaos engineering that I found really helpful. And I find that security people, this is one of those books that really crosses the boundaries. So you may not be able to get them to read the big SRE books, but really this book really kind of has a lot of that same impactful components that'll help kind of bring them along for the ride. So what are the other questions we want to ask here? So do you know if you're under attack at this current moment? Do you know, is that happening inside of your system, and be able to answer that with some level of assurance? Do you know what the attackers are going after? Can you turn on or off services independently if you're being attacked? And are you doing any security chaos experiments? Are you working on trying to inject failure or faults inside? Thanks for being here for the talk. I really appreciate your time today. And as we're kind of making this move, as we're taking security and bridging it inside of SRE, as we're thinking of how DevOps and DevSecOps plays together, it can be really easy to think, how we siloed everybody off before, or how security has to deal with all this other stuff. But really remember, we're trying to make this about the culture, how we're trying to include people. We've broken up this pipeline into 5 different phases, and we did it so that we could understand what are the questions that we face, what are the tooling practices that we need, how can security take part in it, how can SRE help security's job, how do we help make compliance go easier on both sides of it. So I really encourage you, if you get nothing else, get the culture part. Help people be inclusive, bringing DevOps, security, SRE together to try to solve problems together, rallying around the problems, rallying around the which is what we're trying to do, where we're saying engineers can solve problems if you put it in front of them clearly. That's what we're trying to do with this talk, and I hope that it was helpful for you. Reach out to me on Twitter @Wickett or wickett@verica.io if you'd like to email. And until next time, have a good one.